Okay, let's dive into this. Welcome everyone to today's Explainer. We are going to be investigating something that literally surrounds us every single day. And the crazy part? It often goes completely unnoticed, right up until something goes terribly wrong. We're talking about hidden workplace physics, specifically the invisible hazard of stored energy. Now, this isn't just some boring textbook theory. No, we're looking at real-world physical forces that absolutely demand our respect.
To really understand why this matters so much, we have to look at the inciting incident that triggered this entire corrective action module. Picture this, okay? A worker is down inside a confined manhole, just doing some routine sewer maintenance. An inflatable pipe plug is set in place, but due to overinflation, that plug suffers a sudden, incredibly violent blowout. In just a fraction of a second, a totally routine job turns into a catastrophic release of force. So this explainer is all about making sure you know exactly how to prevent that from ever happening again.
Here's our roadmap from mystery to mastery. 1. The invisible hazard. 2. 5 forms of stored energy. 3. The compressed air danger. 4. Recognizing warning signs. 5. Controlling the hazard. And finally, number 6, emergency response. Okay, moving right into section 1, the invisible hazard. What exactly is stored energy? What's really fascinating here is how we define the core of the problem. Stored energy is basically any energy accumulated within a system that can be released unexpectedly. And when it gets released without control, it can move heavy equipment or propel objects at terrifying speeds. But here's the real psychological trap, right? This energy is not always visible. The manual specifically notes that many incidents occur simply because workers tragically assume equipment is de-energized, when in reality, hazardous energy is still quietly trapped inside that system. So the rule of thumb? You must always assume stored energy exists until you have actively verified that it's controlled.
Section 2. 5 forms of stored energy. Let's look at the different types.
And this brilliantly illustrates just how massive a variety of threats we're dealing with here. First up, pneumatic energy, which we just saw with those inflatable pipe plugs and air compressors. Then we have hydraulic energy. Think of excavators and jacks that use pressurized fluid. Those can actually remain pressurized even after the machine is completely shut down. Third is mechanical energy, which is stored in tension springs, flywheels, or belts. Fourth is electrical energy. And remember, things like capacitors can hold a deadly charge long after a machine is unplugged. Finally, gravity. A suspended pipe or an excavator bucket raised in the air, that is potential energy just waiting for gravity to pull it down. You've got to account for all 5 of these before you even think about beginning work.
Section 3. The compressed air danger. Let's talk about this specific hazardous energy.
So the crucial point here is understanding the actual physics at play. Compressed air behaves fundamentally differently than water. Unlike liquids, which generally hold their volume and don't compress much, air compresses significantly. This means as the pressure goes up, the amount of stored energy multiplies. It acts exactly like a giant coiled spring. If containment is lost, say a plug fails or a hose disconnects, that compressed air expands rapidly, releasing all that pent-up energy almost instantaneously.
Let's look at the direct, terrifying consequences of this rapid expansion with inflatable pipe plugs. If you excessively inflate a plug, you are risking a rupture, unpredictable plug movement, or a full-on blowout. This creates a violent projectile hazard, sending flying debris everywhere, which can damage nearby structures and, worst of all, cause serious injury or fatality. And here is a wild fact from the source material. Even relatively low inflation pressures can create incredibly dangerous conditions. Why? Because of the sheer, massive volume of air contained within these large plugs. It's basically a bomb waiting to go off if you don't handle it correctly.
Section 4. Recognizing warning signs. What are the impending failure signs?
You absolutely need an early warning system down in the trenches. Work has to stop immediately if you observe any of these conditions. Are your pressure gauge readings fluctuating unexpectedly, or is the pressure climbing when it shouldn't be? Does the inflatable plug start to shift, rotate, or bulge unevenly? Listen closely. Can you hear air leaking around the plug? Are your hoses vibrating or whipping around? What about your gauges? Are they suddenly unreadable or are the regulators failing? Listen, these aren't just minor inconveniences. They are immediate visual and auditory signs of impending equipment failure. If you see or hear these, you stop. Full stop.
Section 5. Controlling the hazard. Let's dive into hazard controls.
We tackled this invisible beast with two distinct layers of defense. First, we have engineering controls. These are actual physical changes to the equipment designed to reduce hazards. Things like pressure regulators, relief valves, calibrated gauges, safety restraints, and ensuring you are strictly using manufacturer-approved plugs. Engineering controls should always be your very first line of defense. Second, we have administrative controls. This is all about establishing safe work practices. Think written procedures, job hazard analyses, pre-job safety meetings, confined space permits, and supervisor verifications. Put simply, engineering controls change the tool, administrative controls change the behavior.
And then we have our final layer of defense, personal protective equipment, or PPE. Now, I don't want you to look at this as just some boring bureaucratic checklist. This is the literal physical armor you wear when stepping into a high-risk expansion zone. A hard hat, safety glasses with side shields, a high-visibility vest, work gloves, steel-toe boots, and hearing protection. Now, PPE doesn't magically eliminate the hazard of stored energy, but it might just save your life if an uncontrolled release happens.
If you remember only one single thing from this entire explainer, let it be this golden rule from the manual. Pressure shall never be estimated. No exceptions. You never guess. You absolutely must use a calibrated pressure gauge. You have to inflate the equipment slowly, and you must observe that pressure continuously. If it exceeds specs for even a moment, you stop immediately.
And this naturally brings us to the rule of two. Before anyone is permitted to enter a confined space, a second qualified employee must independently verify the pressure reading. The simple, easy redundancy, just getting a second set of eyes on that calibrated gauge, is honestly one of the most effective ways to prevent deadly errors.
Section 6. Emergency Response. What to do with uncontrolled energy.
Okay, if any abnormal condition develops, you must execute this methodical survival sequence. Step 1. Stop work immediately. Step 2. Warn all nearby personnel. Step 3. Move to a safe location. Step 4. Do not approach the equipment under any circumstances. Step 5. Notify your supervisor. And Step 6. Relieve pressure, but only when it can be done safely in accordance with established procedures. After all that, the defective equipment must be removed from service, and the near miss or incident has to be fully documented.
I really want to deliver this next point with the serious weight it deserves. The manual states this explicitly. Employees shall never attempt to hold or restrain a moving inflatable plug. Seriously, do not try to be a hero here. Remember the physics we just discussed? The immense, rapid expansion of compressed air creates physical forces that are just far, far greater than any human being can withstand. If it moves, get out of the way, period.
Let's quickly summarize the ultimate takeaways from the pipe plug incident that sparked all of this. We learned that stored energy hazards develop incredibly rapidly. We learned that overinflation drastically increases your risk profile. We learned that manufacturer limits exist strictly for your safety. And most importantly, we learned that thorough planning, continuous communication, and secondary verifications are the absolute keys to reducing these incidents. Every single employee on site is responsible for recognizing these hazards before the work begins.
So as we wrap things up today, I want to leave you with this provocative thought. What hidden stored energy forces are quietly waiting in your own daily environment? Whether it's a tension spring, a suspended load, or a massive column of compressed air, invisible physics are at play all around us. The next time you step onto a site, don't just look at what's happening on the surface. Look for the energy trapped inside. Thank you so much for joining me for this explainer. Stay safe out there and never underestimate the invisible.